This question is about enthalpy changes. Part A. Table 16.1 shows the enthalpy changes that can be used to determine the enthalpy change of hydration of fluoride ions, F-. Part 1. Explain what is meant by the term enthalpy change of hydration. Enthalpy change definitions are something you need to know from recall, and enthalpy change of hydration can be defined as 1 mole of gaseous, it's important we say gaseous, ions, react, you could say react in water, but react is fine, to form 1 mole, again specifying the quantity is really important in definitions, of aqueous, but you could alternatively say hydrated because of the water that it reacts in, ions. So to get the 2 marks for this question, you need to say 1 mole of gaseous ions react, that's your first mark, and then to form 1 mole of aqueous/hydrated ions is your second mark. Part 2. The enthalpy change of hydration of F- can be determined using the enthalpy changes in table 16.1 and the incomplete energy cycle below. On the dotted lines, add the species present, including state symbols. Let's begin by filling in the lattice enthalpy arrows. Lattice enthalpy is when a solid compound is formed from its gaseous ions. So here I've written our solid product, calcium fluoride, and then its gaseous ions would be Ca2+ gaseous, 2+ because calcium's in group 2 and would have a 2+ charge, plus 2F- gaseous, minus because fluorine's in group 1, and so fluoride ions would have a -1 charge. Now we only have 2 values left in our data table. We have a negative and a positive value for hydration of calcium 2+ and solution of calcium fluoride. So there's only one positive arrow in this energy cycle, and it's here. That means this arrow must represent the solution of calcium fluoride. And so we can fill in this dotted line. Solution of calcium fluoride is when this solid compound produces aqueous ions, or its corresponding aqueous components. And so we can fill in, and it would be Ca2+ aqueous, 2F- aqueous. And then we can fill in the arrow here, which must represent -1609 and +13. And this arrow is representing the hydration of calcium 2+. So that means rather than having Ca2+ gaseous ions, we're going to have aqueous ions, and plus 2F- gaseous because nothing's happened to the fluoride ions. To get the 4 marks for this question, you must have each dotted line with the correct components or ions and the correct state symbols or compounds. Part 3. Calculate the enthalpy change of hydration of fluoride ions, F-. For part 3, we need to look at part 2 again. So here's part 2, and we've almost filled in all the values we're given in the data table and their corresponding arrows. The final one is the lattice enthalpy, which is -2630. So if we just fill that in our energy cycle. Next, we need to fill in a algebra significance for the arrow for enthalpy change of hydration of F-. So this would be 2x. X if it was 1 enthalpy change, but we're using 2 F- ions throughout this whole energy cycle, so we need to say 2x. Now, a bit like a Hess's cycle, rather than going the direct route, we need to work our way around the energy cycle or finding an alternative route for 2x. So this would be plus 1609 minus 2630 plus 13 equals 2x. that means that 2x has the value minus 1008. So what we've done here is just work our way around the energy cycle, find an alternative method, and we're starting in the same place, we're ending in the same place, which means our value will be the same and correct. So then to find x on its own, or the enthalpy change of hydration on its own, we take minus 1008, divide this by 2. That gives us our final x value of minus 504 kilojoules per mole. So on the answer line for part 3, we need to write minus 504 for kilojoules per mole. To get the 2 marks for this question, you get 1 mark for working out what 2x is, so minus 1008, and then 1 mark for dividing by 2 and working out the enthalpy change of hydration, or x, which is minus 504 kilojoules per mole. Part 4. Predict how the enthalpy changes of hydration of F- and Cl- would differ. Explain your answer. Firstly, we need to make a comment on the enthalpy change of hydration values, so what they're going to be like visually. And it's going to be more exothermic, or visually this would mean it would have a bigger negative value than chloride minus ions. The reason for this more negative value is because F- has a smaller size, or a smaller radius, than Cl- ions. And this means that if it's got a smaller atomic radius or a smaller ion size, then it's going to have a greater attraction to water, and that will also impact its more exothermic value, hence making it correct. And we've fully predicted now how the enthalpy changes of hydration of F- and Cl- would differ, with F- being more exothermic because of its smaller size and its attraction to water. To get the 2 marks for this question, you need to comment on the more exothermic value and link it to atomic size, or smaller size ion. And then you need to comment on the fact that F- has a greater attraction to H2O, or water. Part B. Fluorine reacts with steam as shown in the equation below. Average bond enthalpies are shown in the table. Part 1. Explain what is meant by the term average bond enthalpy. So this is one of our definitions we need to learn. So average bond enthalpy can be defined as the breaking, important we say breaking here, of 1 mole, again with definitions specifying quantities is really important, of bonds in gaseous, so here we're stating conditions, molecules. To get the 2 marks for this question, you need to say breaking of 1 mole of bonds, that's your first mark, and then in gaseous molecules is your second mark. Part 2. Calculate the bond enthalpy of the FF bond. Okay, in this type of question, we're going to use the expression reactants minus products. So imagine the arrow for the equation as a minus sign. That's always a good way of remembering this equation. So if we work out the total bond enthalpies of our reactants first, that would be 2x, because we don't know what the FF bond is, plus 2 brackets 2 times 464, because in H2O there are 2 OH bond enthalpies, or bonds, and we've got a stoichiometry saying that there are 2 H2Os, so we need a big 2 in front of this bracket. And then we're going to minus our products. So our products will be 498 plus 4 times 568. And we've got our 4 because there are 4 HF bond enthalpies, and then there is 1 O double bond O from the oxygen. And this is going to equal minus 598 because that is our delta H value. So if we finished off our reactants minus products equation, that would equal delta H. Now we're going to simplify or rearrange this slightly. So we would have 2x plus 1856, all in brackets still, minus 2770 equals minus 598. If we continue to rearrange, this would be 2x plus 1856 equals 2172. So that means 2x equals 316, making x plus 158, which is what we write on our answer line. Adding a plus means that you really know what you're talking about, and it can't be argued that you were like, well, I could have put a minus, I wasn't sure. Putting the plus, extra important, and sometimes it's essential that you put your charge, so plus or minus. For this question, you get your 3 marks. Your first mark from writing the basic equation, where you've worked out the total bond enthalpies of reactants, minus them from the total bond enthalpies of the products, and made it equal delta H. That's your first mark. Then rearranging to the point of 2x equals 316 is your second mark. And then writing x is plus 158 is your third mark.